a live version of our P5 classroom, college algebra. We're going to be looking at, Don't forget to hit that. Of course, you guys are my favorite P5 college algebra class. Absolutely. So we're going to do two objectives today. We're going to verify inverse functions, and then we're going to actually find inverses of functions. Okay? Let's talk a little bit about inverses. Probably your first experience with inverses came in like the end of middle school. All right, do you guys remember graphing with T-charts? Wait for it. There's a little bit of delay, so I apologize. People watching at home.
Oh my God. Sorry.
That's okay. That was just a Jova. Now, hopefully you remember from 8th grade. This is going to be real good, guys. I mean, I've been here for like 15 seconds. Anyway, hopefully you remember from 8th grade when you used a T-chart to graph with an X and a Y. All right, do you guys remember doing that in 8th grade? Hopefully, maybe. And then when you did your first experience with inverses, you switch them like this. All right. Oh, there it is. So you switch them to be the y becomes what you would plug in the x, and your x becomes you put in the y. So when you guys switch your x values and your y values, that is how you find the inverse of a function. So you're going to see that in the work that we do today. Right? One of the steps is to literally switch the letters x and y. Okay? So that was your first experience with inverses. I also want to point out this notation. Hey, just a little bit delayed. Point out this notation. Oh man, somebody's so popular, right? Do you see this notation here that says f? It has a little -1 in the exponent, right? I'll write it a little bit bigger so you can see it. When you see that notation, and in 30 seconds when it shows up on the screen, when you see that notation, it's telling you that what comes after the equal sign is the inverse of the f of x function. Okay, so that's a notation you need to be aware of. I'm not that concerned if you're still figuring out how to use it, but in terms of like recognizing what it means, that will be on tests going on, not just in my class in the future, but also in college. Okay, so that's a notation you need to know. I was trying to wait for it. I waited for it. There it is, right there. Right. I apologize. The name of my channel is Hitting the Board with Mr. Franders, so I have to occasionally hit the board. Okay, so there was an instance there. No one actually jumped out of their seat, so we're good. All right. So this is what I'm talking about. This is the inverse notation. Okay. So let's do a couple together, and then I'll let you guys practice on your own. So I'm going to skip a few. Can you guys go to flip over to, if you flip to the other page where it says at your boards number 4. So find this one where it says at your boards number 4. Give me a second. It's coming. So at your boards number 4. There it is. Okay. So we're going to find the inverse of this function. So first off, check out the notation. What does this notation say? F of x. So this is the original function. And we're trying to find the inverse. All right. We're trying to find the inverse, which the notation is f to the negative first power of x. All right. In 30 seconds it'll show. Okay. So we're trying to use that notation to find the inverse of this. Okay. So first off, do you guys remember this type of function when it says x squared? Do you remember what it's called when it says x squared? What type of function it is? This is important, guys. All these people are listening, right? Not x. It is in the exponent. So very good thought. If the x had been in the exponent, then it would be an exponential function. We're going to get there soon in this semester. So Samantha, we're going to have to go to you again, right? You always get these right. No pressure, Samantha. Do you remember? I'm going to say what it starts with, and that's going to give it away. A Q. Quadratic. Yes. This is a quadratic function. So she just said it? I know, right? Hector? God, you're lucky to sit in front of her. Right? So this is the quadratic function. And we want to find the inverse of this. So I'm going to go through all the steps to do this. So step number 1. All right? Step number one. You're going to write y instead of f of x. Oh yeah, it's been buffering the whole time. All right, you're going to write y equals instead of f of x. All right, see I wrote y equals instead of f of x equals. Everybody good there? That's step one. Step two, you're going to switch the x's and the y's. This is that step that is going to begin the process of finding the inverse. So you see where it says y equals? That's going to say x equals. You see where it says x squared? That's going to say y squared. So only change the letters. Don't change anything else of the problem. So x equals y squared minus 5. So x equals y squared minus 5. That's step number 2. All right, notice, did the square go with the x? Did that exponent of 2 go with the x? No. Right? Everything stays where it is. Only the x and the y switch places. Okay? Actually, you writing this down? You okay? Yeah, let's find the right problem. They're finding it. There we go. Found it. All right. Step number 3. Here's step number 3. Step number 3 is really like multiple steps. You're going to solve for the new y. Step number 3 is really multiple steps to solve for the new y. Another word you might use is isolate for this new y. So I'm going to get it by itself. So what's the first thing I need to do to move something over here with the hopes of isolating for that y? Very good, Christian. I want to move the 5 over with addition. So I'm going to write down x plus 5 equals y squared. So I'm moving that minus 5 over with addition. The minus 5 over with addition. All right? And that will allow me, ooh, sorry. I don't know why I did that. There. All right? So the minus 5 over with addition. It's just give it a moment. Yeah. So.
No.
Oh, go ahead. Yeah.
No, it's fine.
Okay, you good? Okay. All right, everybody good so far? I apologize. Thank you for dealing with the ridiculousness of taking forever to load. Now, is this done? Is this y by itself? It's really close though, right? Because it says equals y, but it's not just y, it's y squared. So how do we take this square and get it to the other side? Square root, I love it. Because the inverse operation of squaring something is taking the square root. God, you guys are so good. Well done. Just positivity. I think he was just smiling and exhaling at the same time. It happens. Okay. Now, at this point, now that we have y by itself equal to the square root of x plus 5, right? To do step 4, you have to ask yourself a question, all right? And really before we ask ourselves that question, let me think back to something you did in, who's my second person? Somebody else. Go ahead. Something you did in Algebra 2, or even Algebra 1, when you were doing solving a quadratics with these, taking the square root of both sides. Gosh, it's really taking a long time. Do you guys remember what you have to do in the problem when you take the square root in your work? There's a symbol you need to put in when you take the square root of both sides. You guys remember what it is? Somebody knows it. I know that. There's a symbol you have to put into the problem when you personally do this, right? See how I personally took the square root of both sides here? So there's a symbol I need to put in front of this square root. Not 3, no. Not a number. It's not a number. A symbol. That is a symbol, but not a negative. But, okay, that's part of it. There's something else with the negative. Positive or negative, which is called plus or minus. Plus or minus. Plus or minus, right here. Plus or minus. Okay? It's okay if you forgot that. I'm not going to be testing you on that on this test, but it's something that you do need to know. Oh, next week. We're going to start reviewing later this week. All right. So this plus or minus is going to impact step 4. All right. So step 4, all right. Step 4 would be to write this in function notation if it's appropriate. But guys, here's the problem, right? If I sketch this, does anyone know what this looks like when you sketch it? Do you know what this looks like when you sketch it? Do you remember? I'll show you if you forgot. Here's what it looks like when it shows you. Here's what it looks like. I just graphed it in orange. You see how it's a parabola but on its side? All right. What's interesting about this parabola on its side? Oh, I didn't even touch that. Oh, it's just because I changed the colors. There you go. There it is. What's interesting about this parabola on its side? This is going to be the worst video of all time. I'm sorry. Not because of you. I want to make sure it's not because of you. It's because there's so much buffering, right? Thank you, building. What's interesting about this? It's not. Right? It's not. No, it's not. So it fails this.
The vertical line?
Yes. So this is not a. It's like my favorite F word. Function. It's not a function. I'm really glad no one said the other F word because we are recording. It's not a function. All right. So because it's not a function, you're not going to do step 4. So this is the answer. Let me write what it would be if it were a function. Okay. So if it were a function, you would write it like this. Okay? So if it were a function, do you see how I did the function notation? Right? You would do this if it was a function. All right? But we're saying it's not a function. Right? This is a very specific case. I want to be very clear with you. Pretty much all the ones you're going to do are going to be functions. Okay? So they're going to have the notation. So just want to make sure we're all good, right? This right here that I'm highlighting, right? That is incorrect, right? This right here is incorrect.
Wait, why is it not a function?
Because it fails the vertical line test everywhere except for the very first point. Okay? The plus or minus, Christian, is the problem. Okay, is everyone feeling okay about that process? Can we do that again one more time, and then we'll stop the recording? Yeah, go ahead. I'll show you how the delta math's going to look here in a moment. You okay, Minerva?
Yeah.
Okay. Let's do one more. Let's do the one right below it. Do you guys see this one right below it? All right. Yeah, it says exit ticket. Obviously, this is not an exit ticket. All right. Trying to make that. It's a little bit below. There you go. All right. So the one below it says f of x equals the cube root of 3x plus 1. Do you guys remember step 1? What's step 1? Not yet. That's going to be later. It's make f of x become y. So y equals the cube root of 3x plus 1. Wait for it. It's going to happen. That's the first step. Is y equals the cube root of 3x plus 1. All right, that's the first one. Yes, very good. That's step 1. What's step 2? Now you got it, Emmanuel. What's step 2? To switch x and y. So we're going to switch x and y. So this is step 1 here that is showing you. There's step 1. I wrote y equals. Now we're going to switch the x and the y. Do I switch anything else? No, just switch the x and the y. All right, so you'll notice I didn't switch anything else. I just switched the x and the y. All right, that's step 2. Step 3 is going to take probably a couple of steps here. Step 3 is to isolate or solve for the new letter y. All right, which you'll notice once I switch it, is buried in this cube root. So how do we get rid of that cube root? What do we do to get rid of this cube root? No, you're right. It's close. You're not going to square both sides because it's a cube root. You're going to raise both sides to what power? Not the second power, the third power. Because of this index of 3, you're going to cube both sides or raise both sides to the third power.
That's what I said, mister. I never said square.
Okay. I wasn't saying that you were like, your brain was doing the right thing, right? It's just we don't say square both sides. We say cube both sides. I trust you. All right. When you cube the cube root, right? When I cube the cube root, those are inverse operations, so they're going to go away. So whatever's inside that radical, which is 3y plus 1, is going to come down. So it should look like this once you cube both sides. All right. Now we're still trying to get y by itself, right? So how do I move that plus 1 to the other side? Subtract 1. So I'm going to subtract 1. So it's x cubed minus 1 equals 3y. Now we're really close. We're really close because it says equals to y, but is it y by itself over there? No. Do you see the 3 that's in front of it? How do we get that 3 to go to the other side? Divide. Nice job. So I'm going to divide both sides by 3. So now I have y equals x cubed minus 1 over 3. All right? Now this is a function. It is the cubic function. Right? If I were to graph it, it would look like a cubic function that you've done in your Algebra 2 class. So I am going to do step 4 here, which is to rewrite this with the inverse notation. All right? And so that is going to be my inverse function for f. So there's my notation coming on the screen here. There it is. That's my inverse of this function. Okay?